Hello everyone, today I am going to explain the fifth problem of AtCoder Beginner Contest 275, which is Sugoroku 4. So Takahashi is playing Sugoroku, a board game. So the board contains n plus 1 square numbered from 0 to n. He has also a roulette wheel. He will spin the wheel and you will get one of these numbers from 1 to m with equal probability. So now let's consider he is at index I, and after rolling the wheel he gets j. Now if I plus j less than equals to n, if I plus j is less than equal to n, he moves to the I plus j squared. If now I plus j is greater than n, what will happen? Now let's consider this Takahashi is at index 3, and let's say he is at here. Takahashi is at index 3. Now he gets j equals to 4. So after rolling the wheel, he gets j equals to 4. Now what will happen? So he will move from 3 to 4. One move is done. Now he in the second move he has to return. So from 4 to 3, there is two moves. Now 3 to 2, the third move. Now 2 to 1, the fourth move. So he will move to the first square. Takahashi's final position will be 1. Initial position is here and final position is here. I hope you got it. This is explained in the problem statement itself. Now what we have to print? We have to print the probability modulo this number. You can check this out also. We have to find the probability modulo this number that Takahashi wins when he may spin the wheel at most k times. So he will win if he gets to the n square. If he gets to the n square, he will win. So we have to find minimum number of not minimum number of spin, the probability that Takahashi will get to the n square with less than equal to k spins. I hope you got it. So now let's check the constants. M less than equals to n, less than equals to 1000. M is from 1 to 10 and k is from 1 to 1000. For this type of problem where the constants are quite low, we are thinking about some kind of order of n squared solution. So what is n squared here? So the first thing you can consider is that n equals to 1000. So one of the parameters could be n. And what would be the second parameter? The second parameter could be k, because we are considering only k moves, at least k moves, at most k moves. So n into k. Now n into k means 1 into 10 to the power 6. So 10 to the power 6 means n into k. Now we can consider this m also, because this is quite low. So n into m into k is order of 10 to the power 7, and for this constants, order of n into m into k will get accepted. Okay, so now let's move on to the solution. So we can think about some parameters. We are just thinking about order of n into k approach. So now let's uh, consider the parameters. The first parameter is the index. Okay, the first parameter is the index, and the second parameter would be the number of moves. Okay, I hope you got it. So now index and moves are given. Now we are spinning the wheel. So let's spin index comma moves, and we are spin, and we get the spin equals to j. So we have to move some kind of function which will take parameters of index and j, and it will give us the our next index according to this. If I plus j less than equals to n, it will give us I plus j, and else it will give us some kind of another index less than I. So f of index comma j comma moves plus 1. I hope you got it. Now what is the time complexity of this? We are iterating over all index comma moves, so it will be order of n into k. Now for every this state, index comma move is a state. Let's consider order of index comma move. Let's consider I comma moves as a state. Now for every state we are just spinning the wheel. I comma moves. For every state we are spinning the wheel. So for this state the complexity will be what? For complexity will be order of m. So the number of state is order of n into k, and for every state we are taking order of n into k times. So our total desired complexity will be order of n into k into order of n in m. So our desired complexity will be order of n in k. So this is quite straightforward. For index move spin equals to j, we are just moving from index f of index comma j to moves plus 1. So this is quite straightforward dp, and the probability will be obviously 1 by m into this. So now let's jump into the solution. Here is my solution. I have taken the input here, and this is a mod value. Now I hope you know this. So let's say we have to print the answer p by q modulus something. So it would be nothing but p into q to the power mod minus 2 percentage mod. So okay, I hope you got it. So now here we are just doing 1 by m, so our q is fixed, so we will just store this value q to the power mod minus 2 equals to inverse. Okay, and we'll just multiply inverse with p whenever required. So now let's jump into the recursive solution. This is the calculating of power in order of log n. You can find it everywhere. You can find it in GFG or YouTube. Binary exponentiation power in log n. Now if moves is greater than k, we'll just return 0. I hope you got it, because we have to consider Takashi wins when he may spin the wheel at most k times. If the number of spin is greater than k, we'll just print -1. Sorry, we'll just return 0 because the probability will be 0 in that case. Now if I equals to n, we are at the final square, we'll just return 1. Now this is the quite straightforward DP case. We will do with this in every recursive DP solution. So we just return dp I moves. So now answer equal to 0. Answer is nothing but dp I moves. We are just storing dp I moves equal to answer at the last step. Now we just consider every value for j equals to 1 to m plus 1. Now the next move is I plus j. Next equals to I plus j. If the next is greater than n, we are just doing this. What we are doing, you can just find this. So let's say this is next. Okay, so this is next. Now we are doing next minus n, and at the end we are just subtracting this 3 from n. So we are just nothing but n minus the parenthesis next minus n. Okay, so n minus parenthesis next minus n. Okay, and now answer equals to answer plus 1 by m is inverse into rake of next comma moves plus 1. This is quite straightforward. If you still have any doubt, you can always ask me in the comment section. Please like the video and subscribe to my channel. Thank you.